Okay, so now that you've seen a few examples of building formula, let me just tell you again the general rules and some hints about notation as such. So the main building blocks, that building block of the element type, is a variable or a term. Where remember, you could do x plus y. If x and y are both numbers, that will be a term. And generally, you use them to construct the simplest formulas, which are a predicate. So one question that people often ask is, what name do you give to predicates and what names do you give to variables? So generally, again, names don't matter. You could always put a y instead of x or something else. But if you don't want your reader to be really confused, you probably want to use some standard notation. Again, if you think about it computationally, if you think about it as computer scientists, you probably don't want to call a variable which is a number as Susan, right? So here is a convention. Just like in arithmetic equations, when you have a variable, an unknown, something that's quantified, you often call it x or y. You could call it x1 or x2, some kind of lowercase letter at the end of the alphabet. You could also use lowercase words like num for number or something like that if you want to give a more descriptive name for your variable. Usually, and again, it's just a convention, letters at the beginning of alphabet, such as A, B, and C, are used to refer to specific element. So if you're thinking of something concrete, you would call it A or B or C. If you're thinking of something generic, you would probably call it X or Y or Z. And for predicates, usually at least here, we use capitalized words. For example, even, less than, and if you don't quite know what the predicate is, but want to just call it some name, so predicate which may change depending on interpretation of your formula, you would call them something like P and Q and so on. So even though you could use any name for your variables, again, just like in programming, you really don't want to call different things by the same name. So for example, even though the formula for all x exists y p of xy and exists y q of xy is a well-formed logic formula, and your machines will not give you an error on that, it may be confusing because as you're looking at the y in the q, you really need to remember that this is not the same y as in p. It is the same x as in p, but not the same y as in p. So often, at least computer scientists take the formulas and they convert it to special form which takes away the ambiguity, called prenex normal form. And what it is first they give every variable a different name. That already takes care of a lot of confusion. Now the second variable in P is called Y, and the second variable in Q is called Z, and it's clear that they refer to potentially different things. And the next thing they do is to take all the quantifiers and put them in front of the formula, and then have the formula with all of those variables as free variables. So this is called the prenex normal form. And it avoids a lot of questions about which quantifiers bind which formula, and also saves you some parentheses. So if you want to write a formula that you will be able to read later, and it's not so big that you really want to think about its pieces separately, you probably want to give variable different names and maybe write them in prenex normal form. So just a reminder Now that you got the variables, how you construct formulas? Well, you have your predicates with free variables. Then you can combine already built pieces, already built formulas using and, or, not, and so on. And whenever you have a formula with a free variable, you could put a quantifier on that variable for every name of that variable in the domain of that variable, the formula, whatever the formula I started with. And again, originally in the predicates and the formulas you built without quantifiers, all the variables were free. You still knew the domains of the variables from the predicates, but now, once you put the quantifiers on them, they are no longer free, so you cannot put another quantifier on the same variable. So one last point is that if you read different textbooks, they will tell you that if you just write for all x f of x, for all x g of x implies h of x, then for all x will bind even stronger than negation. It will only apply to your nearest thing. So to avoid that, it's very good to write parentheses. So if you are writing for all x something and that something is complicated, do yourself a favor and put it in parentheses. So lastly, when you write a formula, please, please, please type check it. Make sure that your ands and ors and nots apply to Boolean. Make sure that your predicates are not taking sets as input if you intend to give them numbers. And also make sure that you don't just list things without actually combining them. I often see on exams people writing things like even of x, comma, odd of x. And my evaluation machine in my brain cannot really understand what it means. Does it mean an and? Does it mean an or? Does it mean, like, if one of them is true and another one is false, is the whole thing true, the whole thing false? You really cannot tell because there is no connective. There are just two disconnected things. It's not a formula, it's two formulas. So if you give even x, comma, odd x to your evaluation machine, well, there is no evaluation machine for comma, and every other machine will say you error, that's not something Boolean, that's something strange. Similarly, if you have exist even x and you give it to your quantifier evaluator machine, it will say, well, wait a moment, where is my x under the existential quantifier? Not only you didn't tell me what set it belongs to, which I can forgive if I know the domain, you didn't even tell me what variable you're talking about. Maybe even has a whole bunch of things in it, and I don't know which one you're talking about. So please, when you're doing quantifiers, write them as quantifier, followed by name of the variable, maybe followed by in set, and then you write a formula, which is well-formed formula of a Boolean type.